Boys and girls, this is Mr. Manise here again with another cool video, and in this video I'm going to walk you through how to work all of the book problems at the end of Chapter 11 to get ready for our Chapter 11 test. And as my disclaimer as always, please do not watch this video before you actually work the problems. I need you guys to work these out first and then go back and watch the video to check, or if you get stuck, you can't figure out how to work a few of these, then come watch the video to figure out how to work them. So as traditional, we have our little GIF, and here is the GIF for this video. Yes, boys and girls, that is Mr. Deshaun Watson with the imaginary bow and arrow after throwing a very long 50-yard touchdown pass, and that is what I like to call awesome. Alright, so here we go. Let's jump on in. So the first question that I assigned was number 1. And for number 1, we have an expression 4r plus 3 minus 9r squared plus 7r. And the directions say they want us to put this in standard form, and then they want us to name it based on the degree and the number of terms. Okay, so standard form, remember standard form, you have to, number 1, you have to combine your like terms if you can, and then you write your term with the highest exponent first. So I noticed right out the gate that I have a 4r and a 7r. I got 4 apples plus 7 apples. That's 11 apples. So I'm going to go ahead and put the term with the highest exponent first. So I'm going to write the negative 9r squared first because that's the highest exponent. And then I'm going to combine my like terms 4r and 11r. 4r and 7r, that's 11r. And then I have my constant. Okay, so now I'm in standard form, and now I have to name it based on degree and the number of terms. So remember, I need 2 words. The first word tells me the degree, and when I have more than one term, I simply look at the highest exponent. I see a 2. So when the highest exponent is a 2, then that's a quadratic. If you can't remember that, you need to go back and look at your table in the first lesson in Chapter 11, 11.1. And then the second word is how many terms I have. I have 1, 2, 3 terms, so that's a quadratic trinomial. Okay, now remember, hint, hint for the test, if they ask you what is the degree of a monomial, you have to add those guys together. So if I ask you what is the degree of something like 14x to the 5th, y to the 8th, okay, on the test, then you have to add those exponents together. That would be a 13th degree, okay, if I have an exponent of 5 and an exponent of 8. Aside from a monomial, if I have more than one term, then yes, I just look at the term with the highest exponent, and that determines the degree. Okay, the next one was number 4. Okay, number 4, we have n to the 3rd plus 4n to the 5th plus n minus n to the 3rd. So once again, I'm kind of focused on what's my highest exponent. It's a 5. I don't have any other exponents of 5, so I'll write that guy first, 4n to the 5th. I don't have any 4s, so I've got some thirds. I've got an n to the 3rd, and I've got a negative n to the 3rd. I have $1 minus $1. Okay, well, what is that? That's just $0. So basically, they just cancel. They just drop out. All right, and then all I have left is just the single n. So I have 4n to the 5th plus n. All right, now if my highest degree is a 5, we don't have any fancy words after the 3rd degree. 0 degree is a constant. 1 is linear. 2 is quadratic, 3 is cubic, and after that we just say 4th degree, 5th degree. So here I would just say this is a 5th degree, and then I have 2 terms. So that would be a 5th degree binomial. Okay, the next one is number 8. Number 8, they want us to simplify, so we have parentheses 6x to the 4th plus 7s squared plus 7 parentheses plus 8s to the 4th minus 11s squared plus 9s, close the parentheses. Okay, so the first thing that I notice in my mind when they say simplify is I'm focused on that guy right there. I see a plus in between those 2 sets of parentheses. Okay, that's very, very important because a lot of students will make the mistake. They'll start distributing. They'll start doing the rainbow, get water to all my flowers, get sunlight to all my flowers. But this is not multiplication. This is not foiling. There's no distributive property. We're not adding any exponents, none of that stuff. We're just adding 2 polynomials. When I add and subtract polynomials, that's just basically combining like terms. So what I notice here is I'm just matching up the same variables, the same bases, and the same exponents. I have an s to the 4th there, and I have an s to the 4th there. So I simply add those together. 6 apples plus 8 apples is 14 apples. So I have 14 s to the 4th. And then do I see any 3s? No, I don't see any 3s here. 2's. Okay, I've got an s squared there and a negative and an s squared there. So I have, and when I'm combining terms, guys, this is literally what I see. Once I match up the s's, this is what my brain sees. I literally only see, see if you don't see that in the video, I literally only see the 7 and the negative 11. So basically this is just integers from middle school. What is 7 minus 11? Okay, that's negative 4. So I have negative 4 s squareds. And then I have a single s. There's no other s to match that up with. And then I have a 7. I have a constant. There's nothing else to match that up with. So my final simplified answer is 14s to the 4th minus 4s squared plus 9s plus 7. Okay, now remember, guys, you can check all these with the calculator. You can use your little calculator trick that I've taught you. Alright, so the next one we have is number 10. The only difference between 8 and 10 is 8 was adding and 10 is going to be subtracting. So I have 8z to the 3rd minus 3z squared minus 7 parentheses subtract z to the 3rd minus z squared plus 9. Okay, so once again my brain is focused on that guy right there. I see a minus in the middle. Okay, so I'm subtracting polynomials. This is still combining like terms, but the catch is when you have a minus, you have to remember to distribute the negative to all three of those terms, which essentially means you just flip all three of the signs inside the parentheses. So I'm going to rewrite this. It's 8z to the 3rd. The first set of parentheses doesn't change. I just bring all this down. And then I'm just going to flip all three of these signs. So that positive z to the 3rd will become a negative z to the 3rd. This negative z squared would become a positive z squared. And then this 9 will become a negative 9. I've just distributed the negative to all three of these terms. Now I'm back to combining like terms. Okay, I've got a 3 here, 8z cubed, and a minus z cubed. Okay, so once again, my brain is just looking at the coefficients. That's an understood 1 right there. So in my mind, I'm basically just doing 8 minus 1. 8z cubed minus 1z cubed is 7z cubed. And then I'm going to match up the 2's, the squareds, negative 3z squared plus a z squared, negative $3 plus $1 is negative $2, so negative 2z squared. And then I just, the constants, negative 7 minus 9, minus 16. Okay, number 12. Number 12. Okay, so we're multiplying here, we're simplifying. I have 4m parentheses 2m plus 9m squared minus 6. Okay, and they say simplify. Okay, simplify. What does that mean? Multiply. Notice, guys, there's no plus sign right here. There's no minus sign between the stuff in front and the other set of parentheses. So there's no operation there. It's understood to be multiplication. So here's where you actually do have to distribute. Use the distributive property to distribute the 4m to all three of these terms. Now remember, back up here, when I'm adding and subtracting like terms, guys, I don't change the base. I don't add exponents. I don't do anything with the base. I'm just adding apples and oranges. S squareds plus x squareds. X's to the 3rds plus x's to the 3rds. But down here, when I'm multiplying, all bets are off. I got to do something different. So when I distribute here, this is where I do my little 3-step process. Signs, coefficients, variables. Get the sign right, multiply the coefficients, then add your exponents on the variables. So positive 4 times positive 2 is an 8. And then when I multiply m times m, you remember that's an understood 1 and understood 1. You have to add those exponents. So that gives me an 8m to the 2nd. 4m times 9m squared, that's positive. 4 times 9 is 36. M to the 1st times m to the 2nd is m to the 3rd. And then 4m times negative 6. Signs, coefficients, variables. Get the sign right. Positive times a negative is a negative. 4m times 6 is just 24m. So I'm left with negative 24m. But the instructions all say to put it in standard form. I'm not in standard form because this guy is first. So I need to write that term first because that's got the highest exponent with the 3. Then I'll write the 8m squared, and then I'll have the negative 24, the minus 24m. Okay, let's move along here. The next one is number 15. Number 15. All right, we've got a negative 2n squared times 5n minus 9 plus 4n squared. Okay, parentheses. Simplify. Okay, so once again, this is multiplying using the distributive property. Signs, coefficients, variables. Negative times a positive is a negative. 2 times 5 is 10. N squared times n, add the exponents, that's an n to the 3rd. Alright, negative 2n times negative 9, negative times a negative is a positive. 2n squared times 9 is just 18n squared. Negative times a positive is negative. 2 times 4 is 8. N squared times n squared, you add those together, that's an n to the 8n to the 4th. Now, standard form, the 4 comes first. Then the next highest exponent is the n cubed. So I'll write that term next. And then the last one, the n squared, comes last, 18n squared. And now I'm in standard form. Okay, let's check this with a calculator, guys. You know I'm real big on that. So let's type in our original problem. I'm going to type in exactly what I see here, the original problem. So I'm going to type negative, don't type minus, type negative 2 alpha n squared. Okay, parentheses, 5 alpha n minus 9 plus 4 alpha n squared. Close the parentheses, and I just want a number. Okay, fine, whatever, negative 560,000, fine. Now let's type in our simplified answer. Negative 8 alpha n raised to the 4th, bring my cursor down, minus 10 alpha n raised to the 3rd, bring my cursor down, plus 18 alpha n squared, and bam, press enter and they match. And guys, you can do this on almost every single problem on the test, so please, after you work the test, go back and check every single one of these that you can. Okay, after 15 we have 17. 17, it says find the GCF, so I have 12p to the 4th plus 16p cubed plus 8p. It says find the GCF, and then it says then factor. Okay, so the GCF, the greatest common factor, the highest number. To figure out the highest number, start with the lowest one. Okay, start with 8 and see if that works. Does 8 go into both of those? No, 8 doesn't go into 12. So now drop 8 down to its next lowest factor, which is 4. Try that one. 4, yes, yes, yes. Okay, so 4 goes into all three. And then they also have something else in common. 4 p's, 3 p's, 1 p. So the most number of p's I can take from them is 1 p. It's always the variable with the lowest exponent, which is a 1. Now I'm going to open up a set of parentheses. Now to figure out what's left over here, I got to go back to each of these terms, the original terms, and divide it by my GCF to see what's left over. 12p to the 4th over 4p, 12 over 4 is 3. P to the 4th over p, remember you got to subtract those exponents. 4 minus that understood 1, that's going to give me a p to the 3rd. 16, positive 16 over positive 4 is 4. P to the 3rd over single p is p squared. 8 over 4 is 2. And p over p, that's understood 1 right there. Those p's just cancel, so I'm left with 2. So the final answer is 4p times 3p cubed plus 4p squared plus 2. Yes, you can use your calculator to check that every single time when it says simplify. Next one, we have number 22. 22. We have 30h to the 5th minus 6h to the 4th minus 15h to the 3rd. Okay, GCF. Start with the lowest number. See if that works. Does 6 go into 15? No. So drop 6 down to its next lowest factor, which is 3. Yes, yes, yes. Okay, so 3 I can pull out. Let me write that a little lower. Okay, what else do they have in common? 5h's, 4h's, 3h's. The variable with the lowest exponent. All three of these guys have 3h's, so I can pull out a 3h's or an h cubed from all three of them. Open up a set of parentheses. Let's divide each of our original terms by our GCF to figure out what's left over for our second factor. 30 over 3 is 10. H to the 5th over h cubed, subtract 5 minus 3, gives me 10h squared. Negative 6 over 3 is a minus 2. H to the 4th over h to the 3rd, subtract, just gives me a single h. And negative 15 over 3 is minus 5, and the h to the 3rds just cancel. So my final answer is 3h cubed times 10h squared minus 2h minus 5. Okay, moving along. Next up, we have number 25. 25. Alright, so simplify each product. Guys, you gotta look for those trigger words. Product, what does that mean in math? That means multiply. 2s minus 3 times 5s plus 4. I really wish they wouldn't use s's and t's. Sometimes my 5s look like s's, but we'll roll with it. Okay, so simplify the product. That means multiply. So here's where we're going to use the FOIL method. First, outside, inside, last. Multiply the two first terms, 2s times 5s. Again, signs, coefficients, variables. 2s times 5s is a 10s. You've got to remember to add the exponents. 10s squared. Outside, 2s times 4 is plus 8s. Multiply the inside. Negative 3 times 5s is minus 15s. And then last, negative 3 times positive 4 is minus 12. Now remember, most of the time, guys, when you FOIL, most of the time you are able to combine these two middle terms. So I got $8 minus $15, so I can combine those. I'll have 10s squared. 8 minus 15 is minus 7s. And then I just bring down the constant, minus 12. 10s squared minus 7s minus 12. Okay, next one we have 26. Oh, this is one of our special cases. Okay, 3r minus 2 squared. Okay, now tomorrow on the test, again, if you know the shortcut, then that's going to save you some time. If you don't know the shortcut, guys, you can still revert back to FOILing this out. If you can't remember what the formula is, just come out here to the side and write it again. 3r minus 2 squared, so it's 3r minus 2 times another 3r minus 2. All right, and then just FOIL it out. First, 9r squared outside minus 6r inside minus another 6r, and then last plus 4. Combine those in the middle and you get 9r squared minus 12r plus 4. Okay, now if you remember the shortcut, when we have a minus b squared, our formula says I square the first term, so I square that, 9r squared. Then the formula says I multiply a times b, so 3r times negative 2 is negative 6r, and then I have to double it. Negative 6r times 2 is negative 12r, and then the formula says you just square this back term. Negative 2 times negative 2 is plus 4. And then notice we got the exact same thing whether we use the shortcut or whether we just FOILed it out. So it's your choice, but the shortcut is just going to save you some time on the test. 27. We have 6g plus 7 times g minus 8. Okay, FOIL first. That's going to give me 6g squared outside. 6g times negative 8 is negative 48g. Right, inside, that's going to give me 7g. And then last, 7 times negative 8 is minus 56. Okay, so remember, I got to combine my like terms. I have negative $48 plus $7. So that's going to give me negative $41 minus 56. And once again, when you're combining those like terms, I just see the coefficients. I'm just doing those integers in my head. Negative 48 plus 7. Check that one. Let's check that one real quick. Parentheses 6 alpha g plus 7 close of parentheses, open parentheses, alpha g minus 8 close of parentheses. Get a number. Okay, fine. Our answer is 6 alpha g squared minus 41 alpha g minus 56. Bam, they match. Move on to the next problem. Awesome. Okay, number 20. Let's see what else we got. 37. Okay, that's a pretty big jump. All the way up to 37. All right, so we have g squared minus 5g minus 14. Okay, and now this says factor. So now we're back to the quiz that we just took, factoring. Okay, so here's where you need to really study that study guide that I handed you guys with the 4 quadrants. Factoring when a is 1, factoring when a is not 1, special case, grouping, all that stuff. So when I see a trinomial, the first thing I'm going to figure out is this a special case? Can I go right to the shortcut? No, I can't, because 14 is not one of our perfect squares. Okay, so now I'm down to, can I pull out a GCF? Is there anything I can factor out? No. So now I'm down to, okay, is this a trinomial? So I've either got to factor it when a is 1 or a is not 1. So the a is the coefficient in the very front of the trinomial. And then notice there's nothing there. There's literally no number there. So when there's nothing there, that is an understood 1. So when that's a 1, all you have to do, guys, and students love to overcomplicate this, all you have to do is look at this back term, the c term, and ask yourself, what times what gives me this back c term? And at the same time, those same two numbers have to add together to give me this b term, the coefficient of the b term. So they have to add to be negative 5. Now when I do this, guys, when you see a number like that, I always think, what are the first two numbers that pops in your head? When you think of 14, what are the first two numbers that pop in your head that multiply give you 14? Almost everybody's going to say 7 and 2. Okay, well, let's start there. Will 7 and a 2 somehow get me to a 5? Yeah, 2 minus 7 or 7 minus 2 will somehow get me to a 5. All right, so it's definitely a 7 and a 2, but now the question is, what are the signs? If this back term, if the C term is negative, that means one of my guys has to be negative, one of my guys has to be positive. And the sign of the middle term, that sign of the B term, determines the sign of the bigger number. So since that's negative, the bigger number 7 has to be negative. Okay, and once you get these two factors, guys, you just write down your two binomials. I mean, there's nothing else to do. There's no splitting, there's no curtain, none of that stuff. When I factor a trinomial, I'm going to have two binomials like this. And you just, whatever letter you're using, if we're using G's, okay, it's going to be a single G there and a single G there. And you literally just write down these two numbers, a minus 7 here and a plus 2 there. That's literally all you do. G minus 7, G plus 2. Okay, let's move on. What else? We've got number 41. Okay, 41, I got an r squared plus 6r minus 40. Okay, let's go through that same hierarchy, same thinking process. Okay, it's not a special case because 40 is not a perfect square. A is 1. There's no GCF that I can pull out. Nothing divides evenly, and the 40 doesn't have an r, so that's an understood 1. So when that's a 1, all I do is what times what gives me negative 40, and at the same time what plus what gives me this 6 in the middle. Okay, so of course I can do this, but let me just show you the little trick again to refresh your memory. On your calculator, go y equals, and then you type in the number you're trying to find factors of. It doesn't matter whether you type in a positive or a negative, it doesn't matter. I'll just do positive 40, and then you press divided by x, and then you press second table. So I'm looking down through this list of values. I'm looking for horizontal combinations that will somehow get me to a 6. Well, there's a 4 and a 10. 4 minus 10 or 10 minus 4, that will get me to a 6. Okay, so I've got a 4 and 10. And now again, the question is which one has to be positive and negative. Since the middle term is positive, the bigger number, the 10, has to be positive, which means the 4 has to be negative. Okay, so that's it. You just write your two binomials. We're using r's, so I'll get an r and an r. And then one of them is a minus 4, and the other one is a positive 10. And that's literally all you do. And again, it doesn't matter the order. I could have put the r plus 10 in front. It won't matter. 2 times 3 is the same thing as 3 times 2. Okay, 44. Now we ramp up the difficulty. I love these problems. I know you guys may not, but I do. A little good old challenge. Alright, so is this a special case? No, 17 is not a perfect square. Can't pull out a GCF. 2 doesn't go into 17. So now I got to factor my trinomial. Notice this number is not 1. Okay, so when a is not 1, we have to do the rainbow thing. We have to factor when a is not 1 by multiplying the first coefficient times the constant, the a times the c. That gives me this temporary number, which is 34. And I got to figure out what are the factors of 34 that add to 35. Well, 34 and 35 are pretty close together, so why not the very first factor in the list? How about 1 and 34? That will get me to a 35. But now the back term is positive, so that means either both of these guys are positive or both of these guys are negative. And if they have to add to be a negative, the only way to do that is if both of my factors are negative. Now here's the hard part. When you do the rainbow thing, the whole point of doing the rainbow and finding factors of this temporary number is so I can split the middle term. I have 3 terms. I can't factor with 3 terms. I need to force it to become 4 terms. So I'm simply going to split this negative 35g. I'm simply going to split it into a negative 1g and a negative 34g. Alright, so I'll put the negative 1 over here. So, and another thing I see students forget is you got to remember to bring down these first and third terms. Okay, we're only messing with the middle term. Everything else on the outside stays the same. So I'll bring down the 2g squared. I'll put a negative g with the 2. So I'm putting the negative 1g over here. I'm going to put the negative 34g over here. Alright, and then I just bring down the fourth term. Alright, so now notice I have 1, 2, 3, 4 terms. I've taken this middle term and split it into negative $35, split into negative $1, and negative $34. Now notice I can group. I can draw my curtain thing. What can I pull out here? And again, guys, I only need to pull out a negative GCF if the front term is negative. This is a positive, so everything on the left is going to be, the GCF is going to be positive. I can't pull out a number, so all I can pull out is a G. What will that leave me with? Well, 2g squared over g is going to leave me with 2g. Negative g over g is just negative 1. All right, now this front term is negative. Okay, I don't care about this anymore. The front term is negative, so I must pull out a negative. Okay, what's the highest number? Well, start with the lowest number. Does 14 go into 34? No. So drop 14 down to its next lowest factor, which is 7. Does 7 go into both? Yes, it does. So I can factor out a -7. That's my GCF. Come back up here, divide both of these terms by -7. Negative over negative is positive. 34g over 7. Oh, wait. I'm sorry. I just had a brain cramp there. You can't pull out a 7. 7 doesn't go into 34. See, I make a brain cramp every once in a while, too. Okay, so 14 doesn't work. 7 doesn't work. So I need to drop 14 down to its next lowest factor, which is what? 2. They're both even, so the best I can pull out is a 2. All right, so if I divide both of these guys by -2, -34g over -2, negative over negative is a positive, that's going to leave me with 17g. Oh my gosh. Okay. Sorry guys. I see what happened. I'm confusing myself here. You guys are probably watching this thinking, what in the world is this man doing? I didn't bring this down correctly. 17. This is supposed to be a 17. 17. Okay. Take 2. This is why checking your work is so important. I literally just copied it down wrong. Okay. Here we go. Take 2. Okay, so the highest GCF that goes into 34 and 17. Does 17 go into 34? Yes, it does. Okay, so I can pull out a -17. All right, if I divide both of these guys by -17, I'll have -34g over -17. That's going to leave me with a positive 2g. 17 over -17 is a -1. So as I was working this out, guys, I realized I was making a mistake because you know what? The 2g minus 1 didn't match the 2g minus 1, and this is why this is such an important, critical part of factoring by grouping is you got to make sure these two guys in binomials match. Okay, so g minus 1 times g minus 1, that's one of my factors, 2g minus 1, and then the other factor is the stuff left over on the outside. I've got a g minus 17, and that is my final answer. Okay, let's continue. All right, after number 44, we have number 51. 51. Okay, 51, I have 10v squared plus 11v minus 8. So once again, this is factoring 8 is not equal to 1. I got to multiply 10 times 8. That's going to give me a temporary number. That's 80. What are the factors of 80 that will add to give you this middle number 11? Okay, so once again, for sake of time in this video, I'm going to let you guys do that on the calculator. Use the calculator trick. What times what gives you -80? And what plus what at the same time gives you a positive 11? And the answer to that is 16 and -5. 16 and -5. All right, so once again, I'm going to split this middle term. I'm going to split it into a 16 and a 5. I'm going to choose to match up the 10 with the 5. That makes more sense to me. So you just bring down the first term, the 10v squared. I'll put the -5v over here. I will put the positive 16v over here, match that up with this -8. So I've taken this 11v and I've split it into a -5v and a 16v. Now I can draw my curtain. The highest number I can pull out is a 5. I can also pull out a v from both of them. Don't forget that variable. And now, to see what's left over, divide both of these guys by 5v. 10v squared over 5v is a 2v. And -5v over 5v is a -1. Those just cancel. And then what can I pull out here? That's a positive, so I don't need to pull out a negative. I'll just pull out a positive 8 goes into both of those. So that's all I can do there. And then that will leave me with, guess what? 2v minus 1. Okay, so that's good. They match. So my final answer is 2v minus 1, the matching set of parentheses, and then the other binomial is the stuff left over on the outside, which is 5v plus 8. Okay, 54. Numero 54. Let's see, we have s squared minus 20s plus 100. Okay, so let's see. What are the factors of 100 that add to -20? But before that, the first thing I noticed is, wait a minute. Okay, that's a perfect square. That's a perfect square. When these first and third terms, guys, are perfect squares, that ought to be a big red flag. Special case, special case, okay? So for it to be a special case, I have to be able to take the square root of the first term. The square root of s squared is just s. I have to be able to take the square root of the back term. The square root of 100 is 10. And then the catchy part, I have to multiply those together. 10 times s is 10s. When I double that, do I get 20s? Yes, I do. So all I do is I throw a parentheses squared around it, and I just bring down this sign. That's it. That's literally all you do. S minus 10 squared. 57, I have 9z squared minus 16. Okay, now I only see two terms. Now the only thing that we've looked at factoring with two terms in the back half of chapter 11 was a difference of squares. Okay, a difference of squares is where I have a plus b times a minus b, and that just comes out to be a squared minus b squared. So if you notice that this first term is a perfect square, which it is, the square root of 9z squared is just 3z, and then you notice you can take the square root of that guy, which is 4. If there's a minus sign in the middle, you have a difference of squares, and all I do is I make this first binomial positive or negative, doesn't matter. One of them is positive, and the other guy is negative. So 3z plus 4, 3z minus 4. That's how you factor a difference of squares. 64, I have, this is a toughie, 32v squared minus 8. That's a toughie. Because you look at that and say, well, it's only two terms, so it's got to be a difference of squares, right? Well, what's the square root of 32v squared? You can't do that. You can't take the square root of both of those, either of those. So in this case, you might be inclined to say, well, it's not factorable. However, remember when I'm factoring, guys, I always want to look to see, is it a special case? Can I take out a GCF? Those are things you need to look for first every single time. Can I pull out a GCF? In this case, I can. Start with the lowest number, 8. Does that go into both? Yes, it does. So I can factor out an 8 from both of these guys. 32v squared over 8 is 4v squared. Negative 8 over 8 is minus 1. Okay, so now if I ignore the 8, now can I factor that? Yes, that's a difference of squares. I can take the square root of 4v, that's just 2v. I can take the square root of 1, which is just 1. And if it's a difference of squares, one of these guys has to be positive, the other one has to be negative. But then you can't forget, you cannot forget this 8. So you just bring this 8 down as the GCF, and that goes in front of your final answer. Okay, next one, home stretch here, guys, home stretch. 66. We have, let's see here. Oh, this is the word problem. Find an expression for the length of a side of a square whose area is 9n squared plus 54n plus 81. Okay, so I have a square, and the area is this trinomial. So of course I'm going to have to factor it. So how do I factor that? Yeah, you can do a times c and get some huge number, but also notice this is a perfect square trinomial. This is a special case. I can take the square root of 9n squared, that's 3n. I can take the square root of 81, that's 9. When I multiply 3n times 9, that's 27n. When I double it, do I get the 54n? Yes, I do. So I just simply throw a parentheses squared around it, and I just bring down the sign. However, that's not what the question is asking for. This is how it factors. This right here, that guy is the area. Well, guess what? We factored it. That guy right there, guess what? That's still the area. These two guys are equivalent. When I factor, I'm not changing anything. I still get the same answer. It's just written in a different way. Just like I can write 9 as 3 squared. Those two things are equivalent. They're just written in a different way. This question is asking for one of the sides. So if the area is 3n plus 9 squared, that means one of the sides is 3n plus 9, and the other side is also 3n plus 9, because when you multiply length times width for a square, you get 3n squared plus 9. 3n plus 9 squared. So the answer is just 3n plus 9. That is one of the sides of my square. Okay. All right, last two here. 68. 68. Find the GCF. The first two terms, GCF the last two terms. All right, so this is grouping. All right, so I got 6y to the third minus 3y squared plus 2y minus 1. You guys, I feel like, are pretty good at this. So let's go ahead and draw our curve. Now the directions say find the GCF of the first two terms and the second two terms. I'm going to go ahead and factor this whole thing. So I can pull out here, down here I can pull out a 3y squared. That's going to leave me with 2y minus 1. Here I can't pull out anything. When you can't pull out anything, all you can do is pull out a 1. And guess what? That's going to leave me with 2y minus 1. They match. 2y minus 1 match. So one of my answers is 2y minus 1. And my other factor is the leftover stuff, 3y squared plus 1. Okay, last one here, guys. Number 70. Number 70. Okay, so I have 6d to the fourth plus 4d cubed minus 6d squared minus 4d. So I see 4 terms, so you're probably thinking, okay, let's go straight to grouping. However, you got to remember, I always want to see if I can pull out a GCF. The first thing I notice is that all of these guys have a d. Okay, also, they're all even, right? They're all divisible by 2. So I can pull out a 2d, and if I divide each of these terms by the 2d, that will leave me with 3d to the third. Subtract those exponents, plus 2d squared minus 3d minus 2. Okay, now let's just ignore the 2d. Let's go ahead and group. What can I pull out here on the left? I can pull out a d squared. Okay, that's going to leave me with, if I divide by d squared, that's going to leave me with 3d. The d squareds cancel, 3d plus 2. Here we go, that front term is negative, so when that front term is negative, I got to pull out a negative, and I can't pull out anything else, so all I can do is pull out a negative 1. Divide both of these guys by negative 1, and I'm going to get 3d plus 2. So that's good. Notice that they match. So one factor is the 3d plus 2, and the other factor is the leftover stuff, d squared minus 1. But then you cannot forget this guy up here, the original GCF, so you just slap that guy on the front end of your final answer. 2d times 3d plus 2 times d squared minus 1. Alright, that's it, guys. Hope you enjoyed this. Hope you're able to figure out any mistakes that you might have made or any misunderstandings. And we will see you on the next video.